Hello student, in this video I am going to discuss about very basic topic about transformation, that is shearing and reflection. We have discussed lots of things regarding the transformations of 2D objects, uh, where their equations, their process, and about composite transformations. All those things have been discussed till now, and this is the last topic regarding that transformation in 2D two dimension, about shearing and reflection. So actually this is simple, same as like the previous transformation. Here also you can see that if you want to shear an object, shear means you are pressing some object in some direction. So here suppose y coordinates are unaffected, suppose you are pressing in that direction, then y coordinate are unaffected. Okay, the y coordinate will be unaffected, but the x coordinates are translated linearly with y. So y dash, but you think like that, suppose originally position of some point was here, but now it is going there, then why not y? Because here the relationship with x only, x coordinates will change linearly with y, but the value of y will same. Here you can see the equation will be like y dash equal to y, means new point of y will be same with the old point of y, but x dash equal to x plus y into h. So here you can see that y value will be multiplied with h. Okay, y value will be multiplied with the h, the shearing factor h, then plus with x, old x, then we'll get the new x dash. So here you can see x dash is related with linearly with y, which is multiplied by the shearing factor. Here you can see, if you translate the same thing in matrix, this is the, suppose this is x dash y dash 1, actually this should be x dash and y dash. So if you multiply that shearing factor into xy y1, that is homogeneous coordinate matrix, here if you multiply 1 into x, okay, then h plus 1 into x plus h into y plus 1 is not recognized because, oh no, sorry, 0 into 1 0, so that is about x dash, and y dash equal to 0x0 plus 1y then 0 1 0. So this is the equation. That way we can get the resultant matrix after we apply the shearing matrix with the original coordinates. So if you apply shearing in that direction, you just need to change the value of x, which is linearly dependent or linearly which is translates linearly with y, and that linear factor is h. So that is all about shearing in that direction. So again, if you want to shear the object in that direction, only that y value will be changed linearly with x. Here you can see this value z is introduced here. So x will be same in this case. This will be x dash equal to x. This will be y dash. So y dash equal to z multiply with x plus y, and the rest will be 0. So here you can see x is multiplied with z, so y will be translated linearly with respect to x multiplied with the shearing factor z, which is applied in that direction. From that, in the y direction, we are applying shearing in the y direction. Okay, then the object will become like this. So shearing will not change the area of the object, means total area will not be changed if you apply the shearing. Next we are going to discuss about reflection. Here you can see we know that reflection is the mirror image, or you can say but occurring in a in an opposite way. We can see here, suppose this is the line, and in this direction we are going to reflect this object, then this will be this one. So here you can see that object has been rotated. Okay, if you go previous, that object was like this way, but when you reflect that thing around this axis, if you reflect that thing around this axis, then it will become like this, and the things will be opposite for that axis perspective. So suppose here again, if you want to reflect this object along the x-axis, then it will become like this. This is a reflection of this object, and in an opposite manner, because it has been rotated oppositely in the direction completely. So this is completely going that direction, complete rotation. Though we are reflecting, we are actually rotating completely, like 180 degree around that axis. Okay, so here what will happen, if you want to reflect, suppose this is the object, this is the old coordinates of the object, then the new object will be here. You can see, if you do the reflection with respect to x-axis, then only the value of y will be changed, and the factor is -1, which will be multiplied with the y factor or y coordinates. So that factor is multiplied with the y coordinates, and the value of x will be remain same. Value of x will be remain same, but value of y will be changed and opposite of the previous value of the object by multiplying with -1. And again, if you want to reflect the object with respect to y, with respect to y-axis, then your that factor will be multiplied with x. So x will be changed, but y will not be changed. So here again you can see -1 is multiplied with this original matrix, and thus you will find the reflection with respect to y-axis. So two factor is that when you rotate an object with respect to y, then then x value changes. If you rotate an object with respect to x, that y value changes by multiplying with -1. And again, if you want to rotate that object by that octant value, okay, this is the third octant. So what will happen? Both x and y value will be changed, which will be multiplied with -1 with the old values of the x and y. So now again, this is one point that you need to think about. Okay, how it will reflect, or how can you reflect an object? Suppose this is the coordinate and this is the line, and your original object is here. Now you need to reflect that object with respect to this line, with respect to this line. Then how can you reflect that object here, and what will be the value of x and y? Okay, try to think about that. Okay, and if you find it tough, please let me know. So what we have learned till now, we have learned about rotation. Okay, this is rotation with respect to origin. Okay, so again we have learned about rotating an object with respect to an arbitrary point. Suppose here you can see, suppose this is the smiley object. We want to rotate that object with respect to this blue box point. Then you need to first translate that object with so that it become with respect to origin. Then you need to apply the rotation with respect to origin. Then again you translate back to the original px py arbitrary position. So that equation will be become like this. So there are first translation occurs, okay, first translation occurs, then rotation occurs, again that reverse translation occurs with respect to the old coordinate. So that is the about composite transformation. Then we have studied the scaling with respect to the origin, then again with respect to a fixed point, okay, or you can say arbitrary point. Here also you need to translate back to the origin, then you have to scale it, then again you have to translate it back, okay. That is all about 2D transformation. So next we are going to discuss about viewing and about some mathematical concept behind viewing, clipping, etc. Actually, suppose in the world coordinate, you need to suppose through your camera you are taking a picture or taking a snap of an object, but whatever part of the object come through the lens will that can be only displayed in the monitor or in the display, but not all the whole view of your perspective from your eyes. So here what things happening is like the viewing of your camera perspective and viewing of your eye perspective, and again after that how can we apply the clipping process, because we are taking only one part of that object which are going to be displayed in the monitor using the computer graphics techniques. So that type of thing will be understand in the next coming topics. So thank you. If you have any doubt also, please let me know regarding the 2D transformation, and try to complete the labs regarding the 2D transformation. That is all about completing the computer graphics lab programs. Then we will go for multimedia programs. Thank you.